Now let's talk about the final class of this series of the momentum, basics of momentum. And in today's class, we'll talk about the collision in the two dimension. Now, before I jump into solving a problem in the collision in two dimension, I'll talk about the basics as usual. So what is the two dimension collision? So in the last class, we talked about the one dimension collision. One dimension collision means if an object is moving along x-axis or moving along y-axis. For that matter, you can call it as east and west or north and south direction. Then that kind of a collision is called as one dimension collision. Now, if the object is moving along two dimensions, for example, along y-axis at the same times, it is moving along the x-axis too. So something like this. This is an example of a two-dimensional problem. So in this one, let's say this is a person. He's moving along this direction at an angle of 30 degrees north of east. Let's say this is east and this is the north direction. So that means this person is covering the displacement in the two dimensions. He's covering the displacement along the east direction also. At the same time, he's covering the displacement along the y direction when he is somewhere down here. So that kind of a problem is called a two-dimensional problem. Now, how to approach a two-dimension problem? A two-dimension problem has to be converted into two one-dimensional problem, two 1D problems. Along one is along x-axis, another is along y-axis. So I'll take a very basic example down here. What we will do is we will basically find out the components of a given vector. So if a person who's moving along is moving along this direction at an angle of 30 degrees north of, this is north of east, and he's somewhere down here, he covered the displacement of 5 meters. I wanted to find out how much displacement he covered in the east direction and how much displacement he covered in the north direction. So what I can do is I'll find out the components of this vector. The component of this vector can be figured out by placing a right angle triangle here. So this becomes a right angle triangle. This component will become, this will be uh, opposite, and then this will be adjacent. So to find out the adjacent upon hypotenuse will be equal to cosine of theta, and the same way opposite upon hypotenuse will be equal to sine of theta. These are the formulas. By applying the formulas, I can find out the adjacent and opposite side. So let's do that. This is cos 30 degree, hypotenuse is 5, this is adjacent. And if you do the calculations, I'll leave the calculation for you guys to do. 5 cos of 30 degrees, and make sure your calculators are in the degree mode to solve these questions, not in radian modes. Then opposite upon hypotenuse, hypotenuse again 5 sine of 30 degrees, and opposite value will come out to be, do the calculation, 2.55, and this comes out to be, I guess, something like 4.33. Okay, I'll do the calculation on my end also. 4 cos 30, yeah, it should be 4.33. Again, my calculator is again in radian mode, so I have to convert it into the degrees. So it will be cos 30 times 5, 4.33. Yes, that's correct. Adjacent side, meters. All right. So you've been able to convert that's how you can convert a two-dimensional vector into two one-dimensional vectors. So this vector down here is in the east direction. This vector here, the vertical vector is in the north direction. Both are positive. This is displacement in north, this is the displacement in the east direction. So hopefully now you have an idea about how you can convert a 2D vector into two one-dimensional vectors. Now this is the approach we will use to simplify the problems for a 2D collision. Now the question is given to us in which a 19.6 kg curling stone A is moving with 1.2 meters per second in the north direction, strikes another identical stone off center and moves off with the velocity of 1.17 at an angle of 12 degrees east of north. and 12 degrees east of north, what will be the velocity of the stone b after the collision? Ignore the frictional and the rotational effect. So how are we gonna simplify this question? So we are given that in this a 19.6 kg curling stone. Okay, let me expand the screen first of all. That's better. Now, in this one, if a 19.6 kg curling stone, I'll draw it on the navigation system. North, this is east, this is south, this one is west, and this curling stone is moving at 1.2 meter in the north direction. So the curling stone, I'm going to draw it here. So sometimes students gets confused why you are showing it in the south direction. So here, one more objective, one more concept of the vectors which I want to teach you. As long as the tip of our arrow is pointing towards the north, you can draw it anywhere. Here, here, here. All these four vectors represent that the object is moving in the north direction. And generally, when we are talking about the collision problems, we take the collision right at the center point so that we can visualize the diagram in a better way. If I'm going to start drawing it here, and then the vector is up here, and then it will be half hard for you to visualize the concept. So thus, I'll start it from down from the south direction and point the arrow towards the north direction. And then there is another ball which is of exactly same mass, which is placed right down here. And this ball, this is curling stone b, this is curling stone a. Curling stone a strikes the curling stone b in the off center direction and moves at 1.17 meters per second at 12 degree east of north. So this curling stone, the a, moves somewhere in this direction, and obviously b will move somewhere in this direction, but we don't know where it will move. So b is somewhere here. We have to find out where does the b end up being at. That's what we wanted to find out. This is va final, which is equal to 1.17 meters per second at an angle of 12 degrees east of north. Now, what I'm going to do is I'm going to try and simplify this question. So again, I will write down the equation of momentum. So I have to break it down. So break it down means I'll write down the momentum equation in x direction and y direction. So momentum in x direction. And before I jump into that, I just wanted to ask you, to tell you that why I've taken the x and y direction now. Why I haven't only kept it as a one dimension problem? So I've been able to figure out that this is a two dimension problem because this vector down here is a two-dimensional vector, and I can see it from the given equation and the direction. So let's write down the momentum equation in x direction. So this is m1 v1 plus m2 v2. Same old story. How many objects are there? There are two objects in this, two curling stones. So m1 v1 plus m2 v2, m1 v1 final plus m2 v2 final. And this is initial, this is initial. That's how we're gonna write the equation. Now this everything has to be in x direction. Everything is in x direction. So mass of the curling stone 1 is 19.6 kg. So 19.6 kg initial velocity it is moving with at 1.2 meters per second, and it is moving in the north direction, so I'll keep it as positive. And v1, that's why this is a positive number. You don't need to specify the positive, but I just showed you so that you're not confused. And plus m2 v2. M2 is stationary. This ball is stationary, although there is mass 19.6. Multiply by 0. Anything multiply by 0, then obviously the answer will be 0, is equal to m1 times v1 final. So m1 is moving in somewhere in northeast direction, somewhere like this. Now what I'm going to do is I need to take the component of this vector in x direction. So this is the vector given to me on on this navigation system, and this is at an angle of 12 degrees. This is given to me east of north, 12 degrees angle. So I need to find out the horizontal component of this. This horizontal component I'll take. And now, while writing this, again, one thing which I missed, I will like to correct it. This initial velocity is also given to me in the north direction. So if this is in the north direction, straight away in the straight in north direction, there is no component of this in the horizontal direction, and we are solving along the x direction. So I will not write it as 1.2. I'll mark it as 0. 0 because the object is moving in the vertical direction straight up. That's why. So this should be 0 and this is 0. And down here, I will take it as 19.6 multiplied by V1, which is 1.17, V1 final, 1.17 multiplied by cos of, uh, cos of, I will use this angle, using the cos, that will be cos of 78 degrees. So you can do also 90 minus 12, which is 78. So this cos of 78 degrees, I'll use it down here, and plus you can use the sine of 12 degrees. Look into the trigonometry via, I mean, how to change the angle. If we are given this angle, if I use this 12 degree, then this component will be represented with sine theta. If I change the angle with respect to the horizontal surface, 78 degrees, then I can use the cosine theta. That's why I've used the cosine here, because I always try to represent the horizontal component with cosine and the vertical component with sine. So I always change the angle. If it is given to me with respect to the vertical line, I'll change the angle with respect to the horizontal line. Here the angle is 12 degree with respect to this vertical line. I change it with respect to the horizontal line so that I can represent the horizontal component with cosine theta. Okay, moving back to the question, M2 V2 final. So M2 is again 19.6. This is not, oops, let me erase this and rewrite this. This is 19.6 V2 FX. That's what we wanted to find out. So V2 final X component. Now, once you're going to solve this, this is 0, this is 0, this is going to move on the other side. So if this moves on the other side, you will be able to find out V2 final X by moving it like this, 19.6 times 1.17 cos of 78 divided by 19.6. So that value will come out to be, if I do the calculation, 19.6 multiplied by 1.17, which is equal to this much, multiplied by cos of 78 degrees, 4.76, negative 4.76 equal to V2 VFX divided by 19.6. So this number divided by 19.6, which comes out to be 0.243. V2 final X 0.243. That's the value you're gonna get for final velocity in X direction. Again, meters per second. This is negative. Negative means it is in the west direction. So 0.243 west meters per second V2 final X. Now, this is, I've solved everything along the X direction. Now I need to solve everything along the Y direction too. So momentum along Y direction. How I'm going to solve that? Again, I'm going to go back into the question and see what's given to me. Now this ball is moving along the north direction. So there is 1.12 north. This is what I have to use. So again, rewriting the equation, m1v1 plus m2v2 equal to m1v1 plus m2v2. This is initial, this is initial, this is final, this is final. And this is in y direction. Everything is in y direction now. Y. And the mass of the curling stone is 19.6. 19.6 multiplied by, it is moving with 1.2 meters per second, and this is positive because this is moving in the north direction, plus m2v2, which is equal to, well, in this case, what I'm going to do, m2v2, this will be 0 because it is stationary initially, and then m1v1 final, which is 19.6, and v1 final value will be uh, v2 final, which is 1.17 sine of 78 degrees. Again, I'll show you why I've taken this 78 degrees. So this angle was given to me 12 degrees. I converted to 78 here, and I've taken the vertical component from here. That's why I've taken the 78 sine of 78 degrees, and plus m2 v2 final. What is the m2 value? M2 value is 19.6 multiplied by v2 final y, uh, which we're trying to find out in this case. So 19.6 multiplied by 1.2. We need to make sure that we take care of the directions. This is a positive number because it is moving up in the north direction. If it was moving somewhere in the downward south direction, so I would have taken this as a negative number. So 19.6 multiplied by 1.2, which is equal to 23.52, equal to, on the other side, I will see 19.6 multiplied by 1.17 sine of 78, which is 22.43 plus 19.6 V2 final. And then this is going to go on the other side, 23.52 minus 22.43 equal to 19.6 V2 final. Dividing both sides by 19.6, 19.6. Again, when you are doing the math, make sure you subtract these two items first, then divide it by this number. Otherwise, your answer will be wrong. So if I do the math here, that will be 23.52 minus 22.43, which is 1.09 divided by 19.6 equal to V2 final. And this number will be a positive number, divided by 19.6, which comes out to be V2 final equal to 0.05561, and this is final in y direction. Now once we've had both the components, I'll redraw both the components, and on the navigation system, this is east component, or the x component I can call it. X component came out to be 0.4243 in the west direction. So I'll draw it down here, 0.243, and this is a positive number, so this will be upwards like this. So this is 0.05561. And then make sure this is a rule of vector, which I'm about to talk now. Vector, this vector is pointing outward, this vector is pointing outward, so the final resultant vector will be somewhere here. You cannot draw the Pythagoras theorem like this. If you're going to draw it like this, that will be wrong. So please make sure you're not applying the vectors like that. So this is the final vector, resultant vector. I'll replace this vector down here because opposite sides of a rectangle are equal. So thus I replace this to this side, 0.05561. I need to make them equal also. So something like this. Okay. And now I can find out this side by applying the Pythagorean theorem. So this will be equal to V final x square plus v in final y square, this is equal to v final, and then square, this will be square root of v final, x is 0.243. Notice even if you're going to take the negative inside here, it's not going to make any difference because negative square will be a positive number, plus 0.05561. Again, even if you don't take the negative, it's not going to make any difference because we've already specified the direction in this diagram. And this is square, and then v final value will come out to be, if you're going to do the calculation, it will come out to be approximately 0.250 meter per second, approximately this number you will get. And then I wanted to find the angle also. The angle value will be, I can use the tangent theta in this case. So tangent theta is equal to, tangent theta is opposite upon adjacent, and the opposite value is 0.05561 divided by 243, 0.243. Theta, tangent theta, oops, this is tangent theta. So theta value will be equal to tangent inverse 0.0556 divided by 0.245243. Again, once you're going to plug this value in calculator, make sure you're plugging them correctly. Otherwise, your answer can be wrong if you are not using the brackets properly. So theta angle will come out to be approximately 12.9 degrees. That's the angle. So final velocity, this value will be equal to v final is equal to 0.250 at an angle of 12.9 degrees. So 12.9 degrees means this angle is 12.9 degrees. And I will write it as, how I'm going to write it? I'll write it as, this is moving from west towards the north. So I'll write it as north of west. That is your final answer for the V final. Hopefully you were able to understand this question. The beauty of the two-dimension problem is that all the questions are exactly the same way. You just need to break it down the components and then get the answer. So if you understood one question, pretty much you can understand all the questions in the two-dimension problem. So hopefully you liked the lecture. If you liked it, think of subscribing it, and I'll see you with another video on another topic. See you. Bye now.